Okay, hello everyone and welcome to our webinar today on Terrain Tools 101. This is the second part, a continuation of the one we did a couple months back, covering off some of the key functions and features of Terrain Tools and different project types you can do in it. My name is Erin. With me today is Dave. We're going to be taking you through 5 different examples here in Terrain Tools, and just get my slide here advancing. So before we officially get started, a little bit of housekeeping. As usual, you are muted. We certainly encourage you to ask questions, engage with us throughout the presentation, and you can use your GoToWebinar panel to do that. There's a little question section, so feel free to ask some questions as we go. And like all of our webinars, it is being recorded. We'll be making this available after the fact on our YouTube page, and everyone who registers gets a direct link to that recording. Okay, so today's webinar, as I said, we're going to be covering off 5 things. Today we're going to be talking about fixing crossing break lines and why it's important to do that, pond design, creating a CutFill map, creating an output sheet in our terrain module, and then how to combine various data sources, various georeferenced data sources. So Terrain Tools is a very versatile program. It can do a ton of different things, and here's just a little bit about what we're not covering with this webinar. And I have a hunch that as we can sort of continue down this Terrain Tools 101 train, we'll actually be doing probably a part 3 that continues to cover some of what's over here on the right. So today we are covering, as I said, it's all about terrain. So Terrain Tools, it's a standalone program on its own. It's called Terrain Tools 3D. And for those of you who are interested in RoadEng or have RoadEng, it also is a module available within our larger product called RoadEng. So with that, I'm actually just going to exit out of this here. Okay, and I'm going to bring up the first example. So today, usually you hear me as a host. I'm actually going to be presenting a couple segments. So to get things started, we're going to be talking about the topic of crossing break lines and why this is an issue. So break lines, by definition, are a line that's used to connect data representing a distinct feature. This could be something like your edge of pavement. Between the points that are defining this line, we actually interpolate the rest of the line so that every piece of that line has a defined elevation. Now, if we've got 2 different break lines, they both have defined elevations across their entire length of their lines. If they cross, we end up with a conflict because those elevations, even if it's a tiny little bit different in terms of their interpolated elevations, it is a conflict when they are crossing. Of course, there is one notable exception to that, and that is if 2 break lines share a crossing point. And if they cross at the same point, there's no conflict. So normally you're not going to find break lines just looking at it, and we've got a nice little piece of survey data here. We're going to find it when we go and create a TIN model. So if we go up here, terrain calculation, we're going to create a TIN model, and we get a break line processing error. It gives us a whole bunch of coordinates here. We could try and go and find those, but truthfully that would be painful. We've got this great tool called XBreak. It's an attribute available in the points window we can use to find and locate crossing break lines. So we're just going to hit OK to go past this one, telling us we've got inconsistent triangles. Hit OK. So let's go and take a look at where these crossing break lines are. So as I said, it's up in the points window. So let's just call that up here. So this is our points window. We can decide what we display in it. And in this case, we want to select features by property. We're going to select our break line property. And then pressing this button down here, display our selected features. We can then sort it by our break line XBreak. That's this column heading here, feature. And we can see that we've got these ones down here. If you can see it at the bottom, it's actually 3 different places where we have crossing break lines because 2 of them are actually the same place. So let's just tackle each of them, talk about why that particular spot is happening and how we can solve it. So the first one is actually probably the easiest. It's right here. You can see this break line is crossing across our intersecting road here. It's a really easy solve. We are just going to break the points on either side and delete the center segment. So I'm just going to go over to oops, of course. So I'm just going to select this point here. go up to my feature tools, and I am going to break it at the current point. Gives me a little error message saying my terrain triangles are going to be cleared. That's totally okay, because at the end of all of this, we're going to be regenerating our tin to confirm that we've fixed all of our crossing break lines. Again, on this side of the intersecting road, go up to feature tools, break at current point, ensuring that only that little tiny segment here of that break line across the driveway is selected, and you can see it's here in magenta. I'm just going to hit delete. So that actually resolves that first crossing break line. Now the next one is a little bit more complicated, and I've selected it here. When you select the issues point in your points window, it actually jumps you to it. I should say it jumps you to the point that's right beside it. So this next one, if you can get a little closer, we have two different break lines. We have our toe of shoulder and, oh sorry, not our toe of shoulder. We have our toe of asphalt and we have our shoulder of asphalt, and it looks like we had 2 points that were possibly misnamed, so our break lines are actually crossing because they've been attached incorrectly. And this, not intuitive at first when we look at it, but it actually is a really common cause of crossing break lines. So to fix this and to solve this one, we need to break and rejoin those segments correctly. And to make it a little bit easier, I'm actually going to just change the line type of one of them so it's a little bit clearer. So just opening up my feature properties panel, I've got my asphalt shoulder here selected. I'm going to change my line type and make my symbols just a little bit bigger. Go up here to something a little bit more noticeable. Change my symbol, something a little bit bigger. Okay, so now I can get a little bit clearer. You can see that we've got these two are mixed up. So what we're going to do is at this point here, we're going to break both the lines and reconnect them. Okay, so pretty easy, break at current point. And then I'm still in my select mode. I'm going to go over here to this one. Again, break at current point. And we are going to start moving them. Now we want to be really careful that we move them in a specific order so that we can make sure we're maintaining where those points were. Go, snapping it, selecting it, and if we click, we can make sure we select the right one. So the toe should be outside of the shoulder, so let's grab that one, edit it, move it over, back to selection mode just one more time. We're going to grab the shoulder, and we're going to edit and move it over. Now if I go back into select mode, holding my shift key, I am able to hit Control J, or we can do that again up here, shift key, hold this, and select join. And that has connected those break lines back together. So let's go for our final example of a break line feature that we need to fix. And that's over here. And wow, I'm zoomed in a lot. Okay, let's just back it up a little. Sorry, there's the last one. So this last one is, again, it takes a second to just orient yourself with where the break line issue is. So this menu with our points will actually take you to the point before. And so if we look down here, so it's brought us here to the next point, but our issue is actually right here. And you can see that this break line is crossing over top of the other one. Now if we go back over to this side of our intersecting driveway, whoa, I'm too zoomed in, they actually share a point. And that's the solve that we're going to use on this side. So really easy solution. We are going to go and we are literally going to just add a point here, and we're going to snap it to this other intersecting piece. So now they're connected. And let's confirm that we've solved all of our crossing break line issues by regenerating our tin terrain calculation. And that's it. So all three of our crossing break line issues have been resolved. And with that, I'm actually going to pass it to Dave. He's going to tackle the next piece of our webinar.
Thanks, Erin.
Oops. Sorry, Dave. There we go. Changing the presenter to you.
Okay, I'm going to use our terrain module, of course. Here we are. Right, so I'm going to create a pond. And I'm starting by working with a brand new empty terrain and putting the original ground in the background. So my terrain is empty, but I want to see the original ground. So let's just add there it is. Zoom extents, and there's my surface. I can hover and find the elevation at any point on the surface, and I'm going to pick an area near here. The surface elevation is 398, so I'm just going to arbitrarily choose 390 as my bottom of pond. So let's start by creating a new feature. I could just draw the bottom of the pond with the mouse, like so. But I'd like to be a little more accurate. So what I'm going to do instead is go into the coordinates edit mode. Control R does that. And change into survey format. And I'm going to type in azimuths and distances. So let's go due north for 100 meters. Add a new point, and we'll go due east for 50 meters. Add a new point, and we'll go south, for 50 meters, like so. Okay. Whoops, that should have been 100 meters. Let's just fix that. Control R, change that to 100. Update list. Okay, there we go. I didn't bother to close it because there's a nice close function here in our features ribbon. There we go. There we go. Right. So I'm looking at the bottom of my pond. It's 100 meters by 50 meters. And just because I can, I'm going to rotate that. So modify selected feature, move size, rotate. There it is. Could have done that with a right click as well. Or even Control M. And I can move it when I see the four-headed arrow. If I move my cursor near the edge, I get the rotation hint. There. Okay, that looks like a good bottom of pond. Now I'm going to build a berm around this pond and then grade the berm down to the original ground. So let's do that. To make the berm, I'm just going to use my buffer function. And I've chosen to make a pond that's 8 meters deep, so I'm going to go 16 meters out. And I'm going to use a slope of 2 to 1. That'll bring it 8 meters up. And now I need to go either left or right. I'm pretty sure I got it on the right, on the correct side with left, so let's just try that. Yeah, there we go. Okay, and you can see the elevation of that is 108. See, these elevations are totally wrong. I must have typed something wrong somewhere, but very easily fixed. So if I select both of these features, and easy to select here because there's nothing in this model except the pond. Everything else is in the background. Right, so I'd like the bottom of the pond, which is currently selected, Control A, select all, to be at elevation 390. I don't know how I managed to get it to 100, but this is how we shift it, 390. Okay, good. So the bottom's 390, the top's 398, and the elevation of the ground is around 399. Perfect. Let's now buffer this out one more time. To make the top of my berm, I'm going to buffer it 2 meters, and this time I don't want to change elevation, so I'll go at a slope of 0. There we go. Now, the outside of my berm needs to go down to the ground, so I'm going to grade it. Terrain modeling, grading. And again, I'm going to the left. I'm grading to the background file, which is the ground, the original ground. And I have to choose a slope. So it's going to be a negative slope of 2 to 1. I don't really care about the positive slope. That's cut. We might have some cut. I'm going to leave that at 100%. And we'll put in slope lines every 10 meters. Turn on all my grading options so that I can get a surface. Don't need contours though. And volumes. Okay, let's just run that. Well, that looks great. Okay, except it's telling me that I've got a fill volume, which is much bigger than my cut volume. And really, shouldn't this be more cut than fill? Yes, I just have to choose which is my original and which is my final. There we go. So it's mostly cut, a tiny bit of fill. Wouldn't it be nice if I could balance this? So I'm going to lift the whole thing up and see if I can make it more balanced. So the graded feature, the outside feature here, is currently at elevation 398. I'm going to lift it up, and I want to lift everything else with it. So I just use Select All or Control A. I've still got the current feature selected as the outside of the top of the berm, 398, and let's do that shift function again. So 398, let's change it to 402. Just guessing here, we have had people asking if we could do this automatically, and the answer is yes, but it requires some programming, and we haven't done that yet, so it's a trial and error process. Okay, so I lifted it up to 402, but now this outer edge is no longer touching the ground, so let's just regrade it. It's still the current feature. If you were a little worried that the other features are selected, you could just select it by itself. That's my outside grading feature, and I'll grade it one more time. I don't have to change any parameters. Just click on OK, and you can see that it makes the outside look quite a bit different. And now my cut volume is a tiny bit smaller than my fill volume, so maybe I need to go down a little bit to balance. Okay, so let's do it one more time. Control A, select all, shift, and let's just go down to 401.8. Again, it's a wild guess, but I tried this before and it seemed to go pretty quickly, so you don't need to go much to get a lot of volume. Okay, and again, regrade the outside. Very important when you're doing your shift to select everything beforehand. Okay, the outside has been regraded. And now I've got a tiny bit more cut than fill, which is generally a better situation to be in. Okay, I'm happy, it's balanced. Oh, you know what? I forgot to set a break line. Let's take a look at the 3D. This is always a good idea. And I might as well look at them both at the same time. So I forgot to set these two features as break lines. And look at the shape I'm getting. So 3D is your friend. It helps you see what's going on. So I'm going to change these two features, this one, and shift-click that one to be break lines. Apply. And now recalculate the volume and the surface. That's better. That's what I wanted to get. Okay, now I'm pretty sure I'm not balanced, so I'm just going to do one more adjustment. Recalculate the volumes. When you do a grading operation, it does a volume calculation automatically if you choose that checkbox, but I can do this independently here. So volume calculation, right, so we've got a lot more cut than fill. Let's lift it up, a meter and leave it at that. So Control A, select all, lift it up 1 meter, let's just call it 403. And recalculate the grade. There we go. Okay, I'm gonna call it quits here. One or two more iterations I could get these to balance. But these numbers are important, of course, if you're doing an actual construction, and you can copy those to the clipboard, and then they come out in a format that will paste into a spreadsheet or a Word document or whatever. Okay. Now, what else do we want to do with our pond? Well, we can see what it looks like. How about a cross-section? So I'm going to throw in a cross-section. New feature, section. And a cross-section should be a draped feature. Draw it with the mouse. Let's snap it onto the corners of the bottom. There we go. And then I'll just Control M for move size. Oops, didn't mean to do that. What I would like to do is pick up the corner of that thing. There we go. There's my, okay, it's falling off the model in the foreground, and you can see it in the 3D window here, but it's not falling off the model in the background. Anyway, I'm going to ignore this error message. There we go, there's my cross-section, and I can see it in the 3D window, and here it is in the cross-section window. And you can see why there's more cut than fill. We've got all this cut here and only a little bit of fill on the berm. Easy enough to make another cross-section. I could duplicate this or draw a new feature. I'll choose the latter. It remembers the property of the current feature, so I don't have to do anything more than just click on mouse, and I'll just draw a feature like so. I've already got one profile window, and you can create, I think, up to 10 of them. Let's just create another one. And there's the long section. So the screen's getting a little crowded. We've got two cross sections, a plan window, and a 3D window. We're going to show you later how to do a multiplot, put those all on a page. And that is my pond example. Oh, one more little thing. How much does this pond hold? What is the volume of the interior? Well, 50 by 100 gives me 5,000 square meters. Times the depth of 8 would be about 40,000 cubic meters. But that doesn't include the sloping sides. So why don't I just pick this boundary feature here, which is at the top of the sloping side, make it into a surface volume boundary, and calculate the volume. So terrain modeling, calculate volume. Volume enclosed by a single surface. This is often used to calculate the volume of a pile. Now I'm using it to calculate the volume of a hole. Did I remember to click apply? No, I didn't. Okay, so the current feature is a surface volume boundary apply. That's better. Do the volume calculation, single surface, use polygons, okay, and there it is. So the extra sloping bit there adds to my 40,000 cubic meters rectangular solid and brings it up to about 61,000. That's if we filled it to the brim. Of course, you'd probably want to leave a meter or so for slopping, and we could take this, buffer it to the inside, do it again, find out what the thing would be if it was a meter less full. I'm going to leave that. Okay, so I've created a surface. How could I, moving on to the next part of our demonstration. I'd like to see a CutFill map. Where is cut, where is fill, and what does that look like? So this is fairly straightforward. Once you have two surfaces, the CutFill map measures the difference between the two surfaces, whether it's positive cut or negative fill. And we do that like this. Save as, regular grid. And I've already got one here, so I'm just going to call this CutFill map number 2. I don't want to write over my existing one. The important thing here is that I want to measure the difference between two surfaces. The foreground, I haven't even named it yet, so it's just called untitled, is surface number 1, and the background, original ground, is surface number 2. Now the top part of this is a little bit complicated because by default it gives you 10,000 points, 100 by 100. And the size of each grid cell is, well, it's not random, it's actually based on the size of the model. So I'm just going to override the defaults here and change these to nice round numbers. Change these to nice round numbers. So there I've told it to export a rectangular grid starting at this corner. And if I put 100 points on each side of my grid, I end up with 2 meter spacing. So let's change that to 200. So I've got 1 meter spacing. Okay, done. I'm going to open this in a new file. And there are all my points. Oh, it's interesting. It kept all the windows from the old file. I don't need those. The 3D view is pretty flat. Come on, zoom extents. There it is. That's my CutFill map. It looks kind of like the elevation of the pond because we've subtracted the elevation of the pond from the original ground, or vice versa. But it's not exactly that. Let's contour this thing. Now these are grid points that are 1 meter apart, so I don't want to include all. I just want to include triangles that are just under 2 meters long. That way I won't get crossing triangles in my concave sections, or long triangles, sorry. Okay, do I need contours? No, because I'm going to show you the CutFill map in colors instead. So make a surface. There it is. And I don't need to look at all these points. They're not giving me any information. I'll just hide them. Disable, displayed, no, apply. Of course, they don't disappear until they're not selected there. That's better. Okay, and now I'm going to turn on shading for my surface. So plan option shading, elevation, and you can see that we go between basically -7 and +6, let's say plus or minus 7 meters. So I'll go from -7 up to 0, and I'll make the -7s, those are my cuts, we'll make those green. And at the bottom, I want dark green, and when it's almost not cutting anymore, oops, that's not what I meant to do. I want a nice light green. So I can choose which color I want, and the number of intervals I want, and the station and the elevation range I want. in this shading intervals dialog, and there they are. Let's do that one more time. Click on Auto Gen. Now I'm doing the fill side, so let's go from 0 up to 7, and I'll use red for fill. And again, near 0, instead of using bright red, I'm going to use a washed out red. So my custom color button, the plus button there, allows me to change that color. Okay, and they got added on the other side. Let's see what that looks like. There we go, there's my CutFill map. And now I'm ready to pass back to Aaron, and let me make sure I know how to do this. Oh, looks like Aaron knows how to do it.
I do. Now let's just make sure I'm showing you guys the right,
Yep,
view here.
You're on the screen.
Okay, so I'm going to be tackling the next, sort of picking it up where Dave left off here and showing you a little bit more about our multi-plot. So that's our built-in output sheet builder. Now we do spend a lot of our webinar time talking about the multi-plot report builder, which is actually from our location module. So I'm really glad actually today we're dedicating a little bit of time to cover the output sheet builder in terrain. Now, we're just going to bring it up here. It's the multi-plot button at the bottom. The two multi-plots, that is the multi-plot in terrain and the multi-plot in location, are actually quite different. Terrain, as you can see here, it is a single page output builder, and it's connected to our screen layouts. So in a few moments I'll demonstrate how we build a page, and then I'm going to call in another layout that I spent a little bit more time building last night, and that's done through a screen layout. Okay, so let's put together a bit of an output page. Now the very first thing we need to do, we need to set up our page size. Shown here on the screen, we've got a vertical format 8.5 by 11. This is not what I want. So to do that, we're going to go over here up to our file button, print setup. So this is the printer that is set right now, and to set it to something like an 11 by 17, that's not capable in my typical printer, I'm going to switch it to my external PDF writer. So our software doesn't include a PDF writer, but as long as you have one installed on your computer, you can access it here as like a printer. I'm going to change the size to tabloids. That's my 11 by 17 and landscape. So that's the first thing I've done with my output page. And now we can go ahead and add some subviews. So up here on the ribbon is our multi-plot tab. So when the multi-plot window is activated and open, we can access the features and functions in this tab that'll appear. So new subview, we can simply just go ahead, and if we have a window open for that particular item, we can add a subview. So we can go ahead and add our plan view, add it to our page here. We can start to add in some of those profiles. I know Dave set up two, but in this example, it's pre-set up here. For me, I've actually got a couple of extra section views, so we can go ahead and add those here. And I should mention, I've actually got my multi-plot set up to help it stay a little bit tidier. So we do have some grid options under multi-plot. I'll go in there one more time. So I just right-clicked multi-plot options, or I could have done it up here through the ribbon. And I've got snap to grid and show grid enabled. And this just from a design perspective helps me keep my page a little bit more organized and keep things lining up nicely. So I've got my spacing set at 5 millimeters. For those of you who work in Imperial, you can set it into inches or fractions of inches as well. And now, so I can just keep adding different subviews to my layout. You can control different options within each subview, and I'll show you that. So to do so, I'll just drop that one in place. We just right-click on the subview. So for this plan subview, we can edit our subview options. We can manually scroll it. That means moving it within there. We can control the bounding rectangle. And then within this option menu, we also have an ability to control things like, adding a north arrow, what's being shown in our background, a few other features, and including our scale. So we could change that within this menu. Is it okay? The other piece that's great to add is we've got a couple other ones that are not official subviews, like from our main windows, but they come in like a scale bar. And these ones actually rescale as we scale them down. So we can place a scale bar in our multi-plot. We could add legends, different terrain files, bring them in. If you've got a company logo, you could bring it in as an image. I'm just going to go ahead now, set up a rectangle. So rectangles are multi-purpose. We've got lots of different reasons for them. For example, I could call this, oops, wow, I can't type, pond project. So we could set that up. We could change the font. So we've got our little title for our multi-plot page, change the font, change our alignment. You could set transparency to it, wrap text, whole bunch of options. So we've just got our pond project, resize that, bring it up here. Okay, so we've got our pond project. There's also within, if you had to add another rectangle, different user-defined options. You can include, what your scale is. As well, from the cut and fill info that Dave was able to generate on that previous example, we could actually bring that in here, paste it in into a rectangle as our cut and fill. So I'm just going to go ahead now and show you what a slightly nicer looking layout did. As I said, created this more than 2 minutes last night. I think it took me about 10. I'm just going to retrieve a layout. So I'm on the View tab, Retrieve Screen Layout, select my pond multi-plot, and here we go. It's there we go, a slightly better looking multi-plot sheet. I've got 4 different section views included. The labels are pulling in from my plan view, and I've got my pond volumes. So this is a very quick introduction to what you can do with multi-plot in terrain. And with that, I'm actually going to pass it back to Dave as we're going to tackle our last piece of the presentation, which is how to combine georeferenced data from a variety of sources.
Thanks very much, Erin. Okay, I'm going to now bring in some data from a completely different source. So let's start by file open here. And I'm going to go and find myself a shape file. So ArcView shape is generally 2D data with attributes, but it's nice because, let me find my example. This is some LiDAR data that we have. There we are. Shape files are nice because they have projections associated with them. There's shape files have multiple files. I'm looking at only the SHP file here, but there's actually 4 or 5 files associated with the SHP. One of them is a PRJ file, and that is the file that contains the projection. Okay, so I'm going to open this up, and I don't need to save that. Right, so I'm going to include attributes, and I'm going to bring this into my empty terrain, but let's look at the projection. So it populated the from and to with the same projection that was built into the shapefile. These are UTM coordinates. But I have some LiDAR data, and the LiDAR data is in a completely different coordinate system. So rather than convert the LiDAR data, which would take a little bit of time, it's totally possible, and there's nothing wrong with doing that. I just don't want you to have to watch while it grinds through 5 million points. So what I'll do instead is I'll change the coordinate projection for the target, or the, we're going to call this new design. We're going to put it into, now I happen to know this number, the EPSG number for BC Alberts. There it is, BC Alberts. But the fact is you can look these things up on the internet, and you can even find these text strings called WKT, which stands for well-known text. One of those really annoying acronyms. Anyway, there's a lot of power here for changing projections. EPSG is a really nice shortcut. So we have some built-in projections here, Universal Transverse Mercator, United States State Plane, and a few others. But if you don't see it on our list, you can enter it with an EPSG number right here. And like I say, it's not hard to find those numbers on the internet. Okay, so now I'm converting from UTM to BCL bears, and therefore I need to apply a transformation. There we go. Now, did that work? Am I in world coordinates? When you have a projection defined, and you can look at it later in the setup, module setup projections tab, then you can always calculate lat-long coordinates from any point on your feature. So I can actually display lat-longs if I wanted to. But here's a really powerful tool that we can't show often enough. You can save as Google Earth. I've already done this, so I'll just use the same file. When you export to Google Earth, you have a choice to do all features or selected features, so you probably wouldn't want to export your LiDAR data. Here we are. I'm just going to select this one file to Google Earth. Now, it was already open, so it didn't take long to get there, but you can see we've got the black line is the line I just exported, and you can see by looking at Google Earth that, yep, there's a road there, and that is sitting right on top of it, and we can see that we're in the right coordinate system. Okay, now that I have a well-defined BCL bears line in my file, let's bring in the LiDAR data. So I'm going to, whoops, not there, here in the home menu, insert file, and I want to open up an LAS file. I've got 2 tiles, but I could select N of them here. 2 is good enough. And when I click on this examine button, the software goes and reads the LAS file and figures out whether you've got point categorization. These files do, and they're about, well, you can see there's 79 million points in the files, but most of them are unclassified. And it's taking just a minute to reread them. Whoops. There we are. So unclassified is 76 million points. Ground points, those are the ones I want, 2.9 million points, and then a few other points of various kinds in there. I'm just going to bring in the ground points. 2.9 million, no problem. We can read all those points if we want to. But as an exercise, let's reduce the number of points we're reading. And I'm going to do that by selecting using a corridor. So I've got a feature in here. I read it in from that shape file. Let's create a corridor that is 200 meters wide, 100 meters each side of this feature. Now, in my import options under selection, I have 2 regions. We'll change the default to decimate the data, read 1 in 20, or skip 19. We'll set up the corridor to read all points, so that's high resolution data. And I think that's all I need to do. There is no defined projection on LAS, so when I click OK, it says, hey, there's no defined projection here. Is this all right? Yes, it's okay. I happen to know that it's BCL bears, and you'll see in just a minute that I got it right. LAS is a nice format. It reads in quickly. So we've gone through all 2.9 million points as of now. And you can see that we've got dense data near the road feature and less dense data outside. And the point count down at the bottom screen is showing me 500,000 points total. Well, I've got very dense data here. The points are practically one on top of each other, and this is typical of LiDAR where there's no canopy. So the roadway was already in existence before the LiDAR was taken, and so we got lots of extra points in there that maybe we don't need. Now, again, there's nothing wrong with working with 5 million or 500,000 points. Let's thin it some more. So we've got in our terrain modeling ribbon, we've got simplify, and I'm just going to take out points. What this does is it doesn't create a fixed perfect grid. What it does, basic grid simplification, is it divides the area up into 2-meter rectangles, and then it picks one point in each rectangle and says that's all I need and throws the rest away. So you'll get points that are roughly 2 meters apart if you set the grid spacing to 2. It's really fast. There we go. And you can see that now I don't have a whole bunch of extra data near the road, and my point count has gone down to 172,000. Let's just quickly take a look at that by generating the surface and some contours. I'll do contours quite far apart so it doesn't take too long. I think we've got points 20 meters apart, sure. Okay, and no labeling. Oops, I didn't mean to click on that button. There we go, there's the 3D view. Oh, when I did the generate tin, I chose spacing of 20 meters, and you can see that in my decimated area outside of the roadway, I've got holes that are actually bigger than 20 meters in size. So they're showing up as holes in the model. Let's change that to 50 and see what happens. That's better. And here's my roadway. Now that I have a surface, I can change it into a draped feature. So I'll do that here and click on apply. And let's look at the plan. Pardon me, I don't need the profile. There we go. So we got the plan, and we got the 3D. And if you zoom in on the 3D, you can see quite clearly that there is a roadway there. And so I know that my 3D data is lined up as well. And everything is georeferenced. And now I can peg in a road, I can draw a polygon, and I can export any of those features back to Google Earth if I want, or bring it into some other software, like, for example, ArcGIS. We do file save as shape. Where is it? There we go. So you can take your line work, you can export it back to shape, and it will create a projection. So that shapefile will be georeferenced, right? PRJ, that will be a georeferenced shapefile. Well, that finishes up for me. The questions panel is open if anybody would like to type in a question.
And seeing as how we also went a little bit long, we are going to, close this out relatively quickly. If you do have any questions, please type them in. We'll probably follow them up after the fact over email with you. But I just want to thank everyone for coming, seeing some of the, the features and functions of our terrain module, and we look forward to answering those questions after the fact. Thanks, everyone.
Bye now.